So, beautiful. Thank you for that. Okay, Fraser, this where do we need ready, mate? Okay.
So, Rannoch Viaduct, for those of you that are not too familiar with it, located in the West Highland Line, one of the most remote stations in the UK. And then just north of that is Career Station, which is the most remote station in the UK, I believe, which was featured on Train Spotting, as many people will be aware of. The viaduct itself was built in, I just checked my notes because I've not put it there, 1894. It was seen as a preferential method to cross Rannoch Moor, the bog that's just beneath it. It's quite a dense peat bog. So the company at the time, which I believe was McAlpine, was one of the ones overseeing it, decided that a viaduct was preferential, which was 9 concrete piers that spanned over a distance of just over 200 metres. It's a longitudinal viaduct, as you can see from the pictures. It's had varying refurbishment work over the time. Before we went in 2024, the last visit was 2008, which was encapsulation of the structure, painting, and general steelwork repairs. Before that, it's difficult to actually find a lot of information about when things were done, but based on the condition of the timbers, it's probably close to about 60 years that they were in the ground up there. Unless anyone can tell me any different, there's not too much out there. So that's just a kind of general picture. One thing I will say is this picture is very, very deceiving because it looks sunny, it looks a beautiful day, and it was that one day, and it completely fooled me into what this place actually is, which is kind of alluded to in the next picture. So that is an aerial shot of Rannoch Moor. There's a book written by Robert Louis Stevenson called Kidnap, which is based on Rannoch Moor, and that's the famous quote from it: "A weary looking desert a man never saw." So it's probably a picture that does paint 1,000 words for us. One of the main issues that we had when planning this job was, how do you get everything there? Because there is a hell of a lot of stuff needed to do what was a full 200-metre bridge deck of timbers. And also, how do you get staff there? Because there's no immediate hotels in the area. And throughout the years, because there's only one hotel close by, various railway staff have been banned from it. So there is a history. So luckily, Amco had never been up here before, so we've been banned. So we were staying just by Kinloch Rannoch, in what was the old, can't remember the name of it now, the Rannoch Rannoch Hotel it was, which was okay for what we needed. There was a lovely hotel literally at the station, but they immediately said, "Well, thank you." So that's just a kind of overview of the picture itself. You can see in the background as well some of the stunning scenery that were dealt with.
Some of those mountains.
So just a kind of an overview of the work. You can see from the picture attached that there's a lot going on. Tie bars feature. The previous picture shows that the maintainers tried desperately, along with the RAM team, to try and hold these timbers in as long as they could. There was vice-like devices, custom made. There was planks of wood nailed across the full kind of 4-foot span to try and hold them. And basically, it was hanging on for dear life by the time this work came all around. We actually went in 6 months before because this area that's pictured was so bad that it had to come out before the job got done. So we did reinstate 2 of these beams, which is 19 and 20 on the right-hand side, which is just the check rail side you can see in the picture there. So these were done just before the job, but it was just as holding works to see us through.
What was the age of the beams that you took out?
That's what it's hard to say. It's about 60 years old.
Right, okay.
That it was difficult to actually see. I was trying to find as much as I could for it before this, but not too much is available. You can also see for the picture there, it's difficult to tell. The AS screws on the check rail side are right on the edge of the beam, which caused an issue in itself. It was a non-compliance the full way through this viaduct, which also led to gauge fouling for the whole lot. So its most foul, it was 110 mil foul to the class 153. So extremely difficult for any kind of works to go on here. It's also worth noting that the local maintainer. Sorry, Gavin, on you go.
What radius of curve were you looking at there, Fraser?
So that's a 210 metre radius curve there.
Oh, quite tight.
So the viaduct, I mean, most kind of viaducts back in the day, they had the courtesy of doing them straight, but this one had a reverse curve at the start of it. 3 separate transition lengths, varying from 25 metre to 33 metre, going from a 210 metre radius to a 238 metre radius curve. It's also heavily canted to accommodate a 30 mile an hour traffic. So it had a lot of kind of difficult geometry settings round about it.
Replacing a way beam in advance.
Yeah.
Was that unintentionally quite handy?
Yeah, it was. It gave us a very much a kind of flavour of what we're dealing with, and more or less gave us a kind of a look under the bonnet of what this viaduct holds, which I'll get onto with another couple of slides, because there was a couple of novel features that we found during this that greatly assisted us for what we needed for the actual main blockade works. So that's just kind of an overview. 200 metre viaduct, 50 timber way beams to be replaced with D70, which is Eckehart. It's timber from West Africa. 32 60 foots for CEN 56, 16 60 foots for UIC 33, 400 UBCR 7s and BCR 4 chairs, 400 NRS 2 chairs, all smalls, high tensile, new holding down arrangements required throughout. So in total, there was 160 tonne of new material and components to be installed over a 9-day period of this viaduct. Each way beam itself weighed 1.5 tonnes. And that again, just with how hard, I never really had an appreciation for different types of timber until this job. But if you've ever seen Eckehart or dealt with it, it is extremely hard. There's still two spare beams that we had left over that are sitting at Soquel Street. If anyone wants to go, I challenge you to try and drill it with an 18-volt drill or a 24. It's impossible. So everything we had to drill was carbide drill bits and high-powered tools to actually get into this wood. So with the sheer volume of materials, again, presents you onto another issue for this site. Where do you store everything? So Rannoch Sidings is the only possible place you could use round about here. There's no other way in for road access, short of going to Turlough, just about, which is near Spain Bridge. We had such a vast volume of material and kind of staff coming in and out that this required a separate programme to actually manage everything to come in. If anyone's ever drove down to the station before, it's more or less a single track road. So you've got 160 tonne of materials coming down a single track road that is, I think it's about an hour and a half from the turn off for the A9. So it's an extremely difficult location to get materials and staff in. That's just a kind of overview of how long it took us to get our materials in. 16 days in total, including the setup of the compound. The timbers themselves, they came in by boat from West Africa to, I think it was Newcastle, and then they were transported up from Newcastle to the local sawmill, and then we took them in deliberate batches to suit our way down. So everything was placed exactly where it was required to be placed for the job.
Was there any consideration to bring in some materials in by train?
We didn't have enough time. So this job was only awarded to us in November of 2023. So we had 5-6 months to get prepared. So there There was no trains. There wasn't there wasn't a lot of stuff. I'm saying November, sorry, it was September.
Right.
It was probably too late in the day as well, because by the time we actually placed the order for the timbers, it was November. So we didn't actually, the dates that you see, I don't think they were long off the boat from until they were arrived up at the site. That's just a kind of visualisation of how foul it was for the 153. You can see the right hand side of the trains catching the actual walkway itself there. So one of the main drivers for this was, how can you physically slow a track that can't be slowed? So the only way we could do it, and luckily I've got the CRE design in here, is by using a different type of check rail chair. So the CC Pan 51 that was located in this is quite a cumbersome unit itself. So it was upgraded to a modern equivalent, which is the Schwehag BCR 7A, and that gave you 120mm to play with, which also gave you the edge protection for the beam, and basically allowed us to manually move this full track over to make this clear. So you can see there, it's not the clearest picture, but the kind of key figure is 12mm gauge clearance is what was achieved by putting this into design. This is a kind of quick overview of the structure itself, from a kind of slice point of view. The only thing to note here, on the right hand side where it shows in red, AECOM, hope it was you, Gordon's, moved the check rail onto the other side of the rail now, so it wasn't the right hand side, the right way first one. I did say it well at the time, but I've used it anyway. So the timbers themselves were the same width to go back in, but as I say, where we had to get the play was the vertical actually profile of these new timbers. Each and every single one was cut to suit for a design. So every single timber that went in the year was to accommodate that exact point in the geometrical design of this. So it was critical that these timbers were cut absolutely perfect. And then that allowed us to move the actual track over to the right, which is on the actual check rail itself. There's a walkway underneath it. One of the problems you've got here is obviously it's a viaduct, so it spans quite a height. So we came up with a solution to try and prevent anyone falling through this, because it's not the safest it looks like when you first walk over this. The actual walkways itself, the right hand side and the left hand side, have been upgraded in the last kind of probably 2008 when the structure was done to Duragrid. So that's more or less fit for purpose for going on. In the forefoot though, it was kind of more akin to chicken wire at times. It wasn't the best. But to be fair, we've done some structural assessment on it, and we've done some safety analysis. We had youngling boards out there, we could walk over it. But it was more or less, once you get familiar with it and accustomed to it, you just kind of forgot you were 100 metres up in the air. We had rope access teams out as well, in case we had to have anything, fall protection. But the kind of key point that we had with this was, sorry, that's just the point on everything I've spoken about before. Show you this picture. So there's a steel plate that goes underneath the actual sleeper itself here, the timber. So once we went in to do the two prep timbers, if you want to call them that, 19 and 20, we found that these steel plates lifted up with the actual beams. So that presented an issue when you're actually trying to remove this, because you don't want them to fall straight down into the moor. So what we've done was realised that by securing these in place to the structure would counteract any fall protection as well. So we spent about 3 to 4 shifts in advance of the actual job, tack welding all these plates into position on the bridge so they were secure. So that kind of resulted in this picture. So that's what it looked like when the full viaduct was stripped down. So that itself, again, a nice picture showing a clear day. Lies, absolute lies. So it was a 9-day programme in total. existing timbers panelled out via a burning team for speed. So we cut every single rail section, existing rail, to suit the actual position of the existing way beams. And that meant we could use the RRV to panel out a full beam, remove all materials as quickly as possible to try and buy us as much time as we could. So that gave us a kind of a good working platform to go off of. Everything was out back down at the scrap area at the station, and gave us time for any steelwork repairs and prep for the bearers landing itself. So this is the kind of first picture just in the night shift when we were setting up for the burning out. I thought it was a good picture to show how well the viaduct was lit up. You can see just a bit. So it looks like an eyesore from anywhere else, but when you're out there, it's so dark that you needed every single bit of light possible. So that was how it looked on a typical night shift, minus the rain, minus the snow. So one of the other problems that we'd encountered previously was how do you lift these beams in when it's single line. Obviously, if you've got a slave road to work off that, you can use slick, use anything, but you're having to work with the actual 1.5 beams, 1.5 ton beams in front of you. So previously, on previous jobs, it's kind of well documented that the best thing you can use is custom lifting eyes. So you actually physically need to drill these in. And the kind of genius part about it is it suits an AS screw. So it means that you can drill in where actually the timber needs to be and lift it with the RRV and the chains effectively. So they were an absolute godsend for this full job, and then another way beam job that we've done in the past. So every single corner of these beams was 3D controlled to land exactly where they had to be. It's kind of wasn't irrelevant as such. It had to be done for our assurance purposes, but you can see how wide the top is with these steel plates. They were going to land exactly where they needed to land. For the width, it was more the longitudinal length that was kind of dictated for. That also gave us setting out points for each base plate for design. That was critical because over such a kind of difficult viaduct, which is jointed, the spacings for all these base plates was no more than 600. So your actual joints for your check rail and your running rail had to be bang on, otherwise you're moving things you've already drilled in place. The right-hand bearer footprint allows the slew using the BCR 7A chairs, as I've said. It's a much wider beam than the left-hand one. And then the lift was achieved using custom depth packers for both the NRS2 chairs, which is on the left, and the BCR 7 chairs. The NRS2 is just the modern equivalent preference from Network Rail for way beam jobs now. So that kind of shows you when the first beam was in, the slave rail that we used to accommodate the design position. So every kind of bit of rail that we burnt out was reused to act as a slave rail, to allow us to physically set where these chairs had to be to design. The reason being, if you try and re-rail during this, it was just going to be way too awkward. So we've done the full bridge with slave rail. We used Revell clamping systems at all times and basically worked our way through the bridge, one beam at a time, to within design tolerances. That proved invaluable when it actually came to re-railing because everything was exactly where it needed to be, and it's just a case of getting the rail physically in the ground. Just an overview of what I said. So we installed from the south to the north, no other option. 12 beams installed to design in a 24-hour period using 2 teams working 12-hour shifts. The Rannoch tea room, which is well worth a visit if anyone's in the area, gave us much needed shelter during what proved to be one of the probably most challenging weather condition sites I've ever worked on myself. Spares for spares, as I said, there was literally no call someone to run up with something. The local maintainer, I phoned them and asked where can we go if we need anything. And was kind of told you're probably quicker going back to Glasgow than you are coming to Fort William. So that was probably one of the kind of key takeaways that we've done for the planning on this. There was no option but to make sure we had enough of everything and then enough more. So there was also the consideration it was a SSI site just at Rannoch Moor. So we decided to use battery plant whenever possible, just to avoid any refueling or fuel getting in. That proved great in conditions of dryness, but the battery plant really did struggle when it was absolutely mincing down the rain and hailstones and the rest of it. Also kind of introduced us to another problem when you've got that many batteries, where do you charge them, which was back in hotel rooms at night for the changeover shifts. The local kind of welfare pod that's there, we thought we could charge all our stuff, but wondered why after the first shift nothing was charging. It's because we were tripping out the full unit. Too many battery tools. So it was good in the face of it, the battery stuff, but we did have to resort to some petrol generator stuff, particularly for when it came to accommodating the cleats that we had to install. So we had to basically hire in a large generator and the planing tool for that with the team of joiners we had on site. Okay, it shows you the first few beams that have landed in progress. You can see the green new cleats that are in place there. It's like all these were fabricated on site with our supplier, and they were all secured down. So it meant that as we were going ahead, we knew what was behind us was more or less done and ready to be re-railed at some point. Still had a lot of snagging to do after that, just to make sure everything was there, but it was an absolute kind of necessity to make sure what we were doing was on the money. Shows you just where we are, just at the kind of middle of the viaduct. So that's beams 11 left and right there. And then just the picture to the right is when we've actually finished, just to kind of show you again the difference in curvature that you're dealing with throughout this full viaduct itself. So integration development, local TME and TSM consulted in advance of the works with the introduction of UIC 33 and the BCR 7s and 4 chairs. We built a test panel for them. That's now up at Fort William. Just if no one's actually seen, the BCR chairs use the Schwehag clip, which is difficult if you've never actually used them before. And then the UIC 33 was the first type for Glasgow North TME. So it gave them familiarisation of what they were dealing with, albeit hopefully they don't have to deal with it within the next 60 years like we did. The loose UIC 33 is not commonly installed in 60-foot lengths. Most of the time the UIC 33 is used in S&C nowadays. That proved, if anyone's seen the kind of profile for it, it looks similar to like an F shape. It doesn't sit up, it's counterbalanced. There's no approved hand tools for it at the time when we'd done this. So we had to find a few kind of bespoke items that were used for Iron Men. We used them for lifting the UIC 33. It was a self-contained clamp. We used that with the RRV to actually hold it. But because the UIC is so thin, it just basically was like a spaghetti noodle at times trying to get it into place. But we got there in the end. But it kind of highlighted a lot of potential issues if you're ever having to replace stuff like this. For drilling it, it's not the easiest because the shape of it, you need an actual specific chambray drill, the arm, you need a backing block for it. So if you're not geared up to actually replace this, it's straight away you're kind of chasing. And then, as I said earlier on, the two contingency beams that we'd ordered just in case anything happened, in case one of them fell in the moor, they're now back at Soquel Street if anyone wants to go and challenge the 18-volt drill test.
Is it that UIC 33? That's on Don Viaduct as well.
Is it?
Yep, just BCR, it's the same base points.
Copycat, sir?
No, we did
it. So, as I was kind of laughing at earlier on, you can see this was the actual weather that we dealt with during the job. I got it lucky because I was day shift, so I never actually got much of the worst of it until you see the kind of peak in the blue around about the 20th of March, which was also my birthday. So it was absolutely hailstones, snow, wind, 40-mile-an-hour gusts nearly, an average temperature of 5 degrees throughout the 9 days. and up to 50 millimetres a day on the 20th and 21st of March. So we got absolutely soaked, absolutely freezing. So Rannoch Viaduct was an absolute godsend for the kind of changeover in between. So how does it look now? Track quality has improved significantly. So this is the trace that I've managed to get. You can see the first kind of CCQ section for the top 35. Previously it was shown as just satisfactory. That's now sitting as good, which is just off the back of the S&C. And then where it was poor previously, you've now got a satisfactory. Everything was into design, but just with the nature of the viaduct and the methodology that was used, you're never going to get this exactly sitting perfect for the maintainer. But there was a drastic increase. So there was an improvement from 7.22 to 4.59 for alignment, and from 4.96 to 3.7. And the latest TRU one, when I looked at it the other night, still showing no faults after a year. So that's also good for us, good kind of longevity as well. And when I spoke to the TME, they've been delighted with everything that we've done up here.
Was there a speed restriction prior to the works?
No. 30 mile an hour over us, but it was kind of well documented that it was life expired. So finished works. Works were complete on time. The viaduct's now gauge clear as per design. Significant life extension with all components over the structure replaced, and more importantly, there was no accidents or incidents throughout the 226-hour programme that was there. That again, last day, nice sunny. Filled us. I never actually, because it was so wet and wild, you couldn't physically take pictures of it when it was like that. So you just need to take my word on it. And probably more the picture that most people have seen is the one on the right hand side, which kind of captures the hills in behind, and just I think that's the one that Transport Scotland have used as well for everything that we've done. Absolutely visually stunning area, but so cold. It was extremely kind of difficult to work with. One thing that I didn't really touch on was the 3D control over this. So we had to install a lot of 3D control over the actual handrails itself, which was great, but you can obviously only set up your instrument over the Duragrid as well. So we were getting a lot of stop, restart the machine, resection it all in again, just because of the movement that was getting seen by people walking. We also had some people that were less kind of familiar with it, as usual with these total stations, marching on right by it, not really understanding what we were doing at the time. So it was a difficult job to 3D control throughout.
I've seen a few monitoring installations recently where the total station mounted on a sort of clamp on a overhead line mast, for example.
Oh, yeah.
I don't know if that would be an eruption there or not, or if it would have been moving about too much. That hand
Moving about too much, I think it's the actual.
moves on that.
That viaduct.
I suppose with the
Wind that would have been difficult for the 3D control.
Yeah.
So I've got no other kind of points. It's just a kind of thank you to the key suppliers, because I've not actually presented this since we've done it 20 months ago nearly. So I better start with ACOM since the CRE designs in the room.
No, that wasn't me. I was only the check.
Oh,
I can't take credit for it. It was Stephen that was the. There was lots of coordinate checking went on. That's all I'm going to say.
Yeah, so set rail services ready for Thornbridge Timber was the supplier for the beams, Torrent Trackside for everything, Rannoch Viaduct, Network Rail itself. There's a great kind of back and forth we had between Jonathan, Zoe Monkhouse, Andy Sinclair throughout the full kind of process of this, Jeff McGee as well. ACOM for the designers, Direct Track Solution for all the smalls, all the kind of chairs we got, KLR for the joiners and rope access, and then Schweehag for all the BCR chairs and the kind of rigmarole that went around getting them in the country. And that's just another kind of scenic picture, not mine. I removed the copyright image off it last night though, so I'll wait till you go for it. So yeah, thank you. I didn't want to kind of bore you to death with it, but it's more one that's open to questions or discussions about the difficulties that go with jobs like this, particularly in remote areas. So if you've got any questions, then please fire away.
A couple online. Lynn has asked, I know you mentioned it, the gauging was clear at the end of it. She's asked, did the as-built gauging design show the clearance to be? Was there a value? Did it hit the value you were looking for?
She's been talking to Siobhan. So we were contracted to to build this. So all our tolerances are within 2102 tolerances for what this job was needed. It was ACOM that were in to actually do the as-built for everything. And when I said to Siobhan last night, I better go and check the clear runs and see if this is here. But the last upload was 2022.
Okay.
So it's not been uploaded to the system yet, but it's into the design. So my answer is yes, Lynn. We've achieved the clearance. It's definitely 100% better than it was, but there was a whole kind of rack of still, even though we tried to reduce the non-conformances, just with the process that goes around way beams. You're restricted how far you can be from the end of a beam for base plates. You're restricted to how close you can be to the edge. Your spacings can't be any wider than 550, 600. So you're kind of, I could bring up the actual drawing, which we'll do after the online meeting, and show how kind of restrictive it was. But the actual job itself was not fully how you would want a kind of a job to be, in terms of there was still non-conformances. But
Your holding down clicks don't help either. They bugger up the spacing.
yeah, holding down cleats as well. It was holding down cleats 2 per beam, which I think the Network Rail standard was they wanted 3, but that was a derogation that went in for the civils. There was also, as I say, the difficulty we had with offsetting the UIC check rail plates and the actual flat bottom check rail plates as well, because you still need to be able to maintain it. So all your bolts need to be facing out the way for the maintainer to get in. So it was a challenging site from that sense. And then just to kind of make matters better, when you get off the viaduct to the north end, you're butting onto the billhead check. So we had to then put in an air gap as well. So that was a custom air gap that went in, which is a chamfered UIC 33, and then a new chamfered billhead check to accommodate it.
There's still a lot of room for renewal and improvement, isn't there, on that line?
Yes.
It's a disgrace, really. Really upsets me.
Martin McMillan's asked online, was there any aspirations to raise the line speed, or were you restricted by the tape radius?
Restricted by the actual geometry here itself, because how tight the radius is. I don't think that would have went too well with structures either, from our point of view, just on the edge of the viaduct. If we were to increase it, it's a 30 mile an hour curve here, which, to be honest, the freight train picture, I think, would even probably struggle to get up that gradient. It is one of the steepest gradients in the West Highland line here.
Is it 150 or something, isn't it? Or late? I think it's steeper than 150. It's
Steeper.
147 or something.
It's
also running into the station, which is 15 mile an hour.
Yeah, it's running in. It's one where it's actually non-compliant to even use a bogie on this line. There's a whole kind of rack of issues that go with the gradient itself. Probably one in the future, if there was any line speed improvements, I think this would still be a bottleneck just based on the geometry going around this viaduct, and the fact everything more or less stops apart from the freight at the station. So no, unfortunately, there wasn't anything from our end as a construction contractor to engage it, but I believe that was ruled out because of the actual structure itself rather than the geometry.
Does the speed not change?
Changes right off the end of the viaduct to 40.
Gavin asked a question on logistics related. Did you have a mobile phone signal?
We did actually, mobile phone. You don't get a signal. It was intermittent. It was intermittent, to be fair, but we did have a signal. One thing, I mean, the picture itself doesn't really do it justice, but as a bog down there, so we drew straws at the end. We had to go down to the bog and pick up all the bits that had inevitably fell off throughout the 9 days. So I've got a couple of pictures of folk and waders having to go down and pick up the odd pandro that had clipped, fell off, and inevitably bits and pieces. But we managed to get full site tidy done. The locals just at the station, we kept in touch with at all times. There's a kind of fishing lodge there as well, and they were a good kind of company. They would come out and see us what we were doing, and the kind of local community really did rally behind this work. Gave us some help, especially with the Rannoch Viaduct. They opened at 4 o'clock every morning to feed us, and then lunchtime as well.
Fraser, see your slave rules. Did you use the, it's 200 and whatever it is, did you use did you use the pre-curve?
No.
No.
So we made the decision at the start, myself and Jonathan, about pre-curving the rails. It was an option that we considered, but again, because your logistics here, like pre-curved rails, your laydown area is so restrictive for that you're kind of shoehorning yourself in for another issue. So everything, it gave us more of an issue to put in, particularly around the tighter radius. But because you're going 60 foot at a time, it gave you enough to work with. Any shorter than 60 foot, I think you would have really struggled to actually manipulate it, but it was good.
3D coordinates for the ends of the joints as well as the base plates.
Yep, everything was 3D controlled off a SEP. So we had SEP out for the set out as well. So SEP were invaluable for us. So
Is there an actual water course done by that?
You can see water running. I don't actually know if it's officially a water course or not, if it's just classed as a bog, but the Rannoch Viaduk's got a wee museum right beside it, which they maintain and kind of show, and they've got a couple of, I think there's a poster on their wall saying what survives in a peat bog, and the answer is quite a lot. So there's lots and lots of wildlife around about there, which is obviously the driver for the SSI and the importance of making sure everything was preserved as best as possible.
Did you come under any pressure to have something to stop stuff falling off the viaduct into that?
We did. So we did initially look at encapsulation, which was just way too expensive for the civils budget that we had, or Network Rail had, sorry. That was then, how do we prevent anything? So the main kind of problem was the steel plates themselves had a lot of kind of residue and oil on them. That was the main risk of getting into the watercourse down beneath. But Network Rail Maintenance have got an agreement with the SSI for a maintenance work over here, which is the likes of standard maintenance practices allowed for working over an SSI. So we used that via our environmental contacts, but everything was kind of, as I said, there was no fuel spillages, there was no heavy debris that went in, apart from the odd plastic bag that we went down and retrieved at the end. Everything else was maintained.
A few more questions online. So Shweeb has asked, was there any cost saving in terms of waste components? Were there any old components used or were they refurbished? If so, can these be used in other projects to further reduce costs and be more sustainable?
No, was the short answer, mainly because from tying into the maintainer, due to the remoteness of this area, we didn't want to put anything refurbished back in. We wanted all this to be new. Reason being, you don't want to have to come back to this anytime soon. It's so challenging. Everything was recycled via Network Rail's MR1 process, so everything that came off the viaduct was sent away to recycling plants at Kingmoor and various other places. So it will be reused somewhere else in the world, but not in Rannoch Moor, thankfully. It would have presented more challenges to try and reuse materials than anything else as well.
Again, from Shub said, was there further structural examination carried out prior to the work and other disciplines involved to restrict you from carrying out the work, i.e. delays, pause to rectify assessment conditions, etc.?
So this full job was part of a separate civils Form AB process, which everything was IDC'd and jointly reviewed. They more or less provided the structural assessment and made sure that everything that was going on was viable for the actual viaduct itself. But there was nothing else untowards for that now.
Were synthetic or composite materials considered in the way beams rather than hardwood?
Synthetic was considered at Form A, Form B, but the problem was at the time, because it was so new, the lengths were a big issue. So I think at the time, off the top of my head, it was 6.6 metres was the biggest that could come in via FFU from Japan. And that presented a whole other logistical problem, because it had to come in from Japan to the assembly yard at Hull to be reused, to be then joined together to brought up to Rannoch itself. So that was discounted before we actually received the drawing, but it was documented in the Form AB as an option that was considered.
That's now up to 9 metres, you can get them 9 metres.
9 metres now, yeah.
Or 8 or 9, I can't remember. The job that I was working on in Conway, they spoke to us about that. It was either 8 or 9.
Yeah, at the time all this was developed, it was 2021, 2022, so FFUs were just coming in. But I know now, particularly from speaking to Zoe, that the FFUs are definitely probably the way to go for the future of these, rather than the hardwood that we got.
It's Andrew Anderson that asked that question, so thanks for that question, Andrew. Mara McMullen's asked another question. What is the expected life expectancy of the new longitudinal timbers in normal conditions? And what is expected in the exposed moor? Is there a variation expected because of the environment?
I will have to pass on that. I don't actually know. I know that the standard answer would be 50 years minimum for this, but as I say, because you're so exposed up here, I don't know how long the softwoods were in to degrade in such a way they did. But I can tell you it'll be a long time before those hardwood timbers see any damage at all, because the weather were ridiculously hard wearing. As I say, my naivety around different types of timber was kind of put to bed very quickly when I tried to drill into this. So yeah, there was no clear kind of indication how long this will last, but if I had to say, I reckon no one that's on this call now will ever have to do that again.
What's the difference in weight between the new components compared to the previous one?
So I think the difference in the actual timber itself was close to 700 kilos heavier. I'll need to check exactly what that was, but the softwoods themselves were, you could, as soon as you lifted them out, they would crumble. But from working with hardwood, it's extremely durable for what it is. 1.5 tons is what each one of these beams weighed. And then, as I say, I think they were just under 900 kilos, 800 kilos for the existing softwoods that came out.
Yeah, more durable, but what's about the structure underneath that? That's all been checked.
That had all been checked off the civils team, yeah. So that had all been structurally analysed. That was one of the main drivers for this, because of the weight that we're putting on it.
Was that 700 over the whole structure? 700 kilograms?
700, no, each beam.
Okay, sorry.
So there was a significant increase in the structure. As I said, I think the 2008 works that had carried place previously were probably part of the strengthening works for this viaduct to accommodate this in the future. But we went as a contractor to actually build this. It wasn't something we were privy to. It was more the constructability of doing it.
Yeah, some of that back from the Czech Railway later.
Yeah. I got the AFC for this 2 days before the job, so it was great.
Jonathan?
Yeah, it's interesting from an asset management perspective that obviously we had to put the UIC check rail in here, but it's part of obviously this. It works with like the it's NRS base plates.
NRS2, yeah.
But they're much better, I think, because of the higher toll load than the traditional stuff. So I suppose my question is what was it like to work with the UIC 33 check rail? Because I think people perceive it as difficult. However, I seen the prep that you and your team put into this, and it was incredible. Like, I was blown away by the work that Amco did on this. So You may have found it actually not too bad because you put so much prep in when you spoke about the test section and everything else you did.
It's difficult because the UIC check rail is really, really good. When you look at the principles of it, the face wears away rather than what would typically happen with bullhead check rail. So it's designed to wear away that you can then replace easily enough if it's seen as much flangback contact as what you would see. From a workability point of view, changing, if you look at it from just changing a 60-foot rail to changing a 60-foot section of UIC, it's a nightmare because, as I say, you can't physically lift it. It counterbalances itself. There is tools on the continent that I'd found by doing some research at the time 2 years ago that were in Germany that they were more or less for this, but it wasn't product approved for network rail at the time. So I did try to kind of push that through, but it wasn't an option. And things have probably changed now based on more of this being introduced, but it was typically UIC from when I worked with it before was an S&C check rail that was used to accommodate the junctions. So it all came panelised, so nobody really had to worry about it too much.
Yeah, no, 60 stuff, so UIC.
So in short, if you're doing UIC 33, be prepared is the kind of warning I would say, particularly if you're having to drill it, because it's not as straightforward. We spent a lot of time, because you had bullhead here, you had flat bottom, and you had UIC 33 all over the space of a 200-metre section. So I had 4 different rail drills set up to accommodate each section. So you can imagine my frustration when I came out one day and someone had changed one of my drills to suit something else, and I didn't know where that part had gone then. So that was incredibly challenging to try and find my drill that went missing in the middle of a moor. But yeah, it's the kind of long short of it is it's probably the best component you could have up here. It's the right thing to do. It's very, very difficult to work with from a maintainer's point of view, is what I would say if you had to replace it.
Last question, I think, from online. Gavin was just asking, was there any monitoring post-works?
Yeah, well, there was monitoring done over the structure itself, but it was more so because we had tamping overlaps as well to see on either side. So there was about 200 metres either side of this that get tamped, as well as forged transition rails to go in where it joins from the bullhead to flat bottom. So we monitored locally off the ends of the viaduct itself, but physically on it, the beams are restrained to where they can move via the hold down arrangement, and via everything else it's actually securing it. So there wasn't any structural monitoring carried out for the way beams, but in accordance to 7177, we did have either side on the bars each section.
Any other questions in the room? Online? No. All right. So, Fraser, I'd just like to thank you very much for an excellent presentation. Looks like a very successful job in highly challenging surroundings, and quite a lot of sort of lessons learned and problems overcome, solutions that you'll probably benefit from, and others that in the presentation can learn from as well. So, everybody could just join me in giving Fraser a round of applause. And thanks everyone for joined online. I'll just share this upcoming events that we've got coming. Seconds. See if we can go first here on that. Johnny, do you want to?
Yeah, so obviously the previous ones from Tom and the stuff on the name change is on Knowledge Hub. It's quite a good discussion on the name change, and there's really good stuff online about that. Obviously the voting's open now as well. So, Fraser, we've got Jason Robertson from Scott Parnell coming in next month in December. Some really cutting edge stuff from Scott Parnell, so looking forward to that. Andy Steele's coming in from QTS. He's chief exec, I think he is, QTS. So that'll be quite a good one as well, to get someone so senior in the industry coming along. He's going to do a piece on innovation in the railway and kind of some of how QTS do a lot of that stuff, which is, they're pretty good at that kind of thing. So it's not easy either. So that'll be really good. Konstantin Popov is coming in from Smart Technology in February to give us some of the detail on some of the new remote track monitoring that's available. I didn't put the names down because I can't remember who's lined up for this, but obviously we've got the Burnhouse job this Christmas, haven't we?
Yes.
Which is huge. I can't know, is it 17 point ends or?
A huge job, yeah.
Yeah, so like, so yeah, it'd be good to get kind of some feedback on the challenges and how that went, etc. So yeah, it's one of these mega jobs, so that'll be great. And then Jerry Fitzsimmons from the Initiate team's coming in May, and he's going to give us some detail on that Initiate system. Some people in the room might know about it. I'm not too up on it, but it's the modern way of taking possessions, essentially. So that's coming in across the country and getting rolled out across Scotland as we speak. We're going to try and get a tour of Glasgow Central in February, so we're going to try and set that up for people that are interested. And then she hasn't confirmed yet, but we're going to try and it'll probably be online, but maybe in person, get a presidential address from Charisma Jane, the new president.
Excellent. Well, hope to see lots of the upcoming meetings. And thanks again, everybody online who's joined us. I'll just call it a day there, I think. Thank you.
What's the general?
Thanks very much.
Thanks,
Cheers,
Fraser.
guys. Thank you very much. Cheers. Good night.
Cheers.
Thanks, David. Thanks, Fraser.